generating a lot of data and require analysis of that data, it doesn't really matter if it's financial data, genomic data, media and entertainment, rendering wireframes and patterns and things like that. If you have a workflow that is I/O intensive and reads a lot of data and creates results, and you want to push that back on-prem, I mean, I think this is something that might be working for you. And throughout this demo, we're going to kind of walk through some of those scenarios. So when we talk about the demo environment here, essentially, this slide did not go as expected on the BrightTalk, but no big deal. So essentially here in the middle, where the big white space is the Google Compute environment. Let's see if it came on the next one. Oh, okay. There we go. All right. So the Google Cloud Project is the environment where you're going to deploy your cloud resources, and essentially that's where your compute is going to live, and that's where your VFXTs are going to be deployed. And what we're showing here is that you have an orchestrator, a human, that's running commands to set all this up, or perhaps it's an automated process. But essentially, you have a host either running inside of the Google Cloud Project, or you have the Google G Cloud libraries installed on your machine, and you have credentials set up and whatnot. But essentially, you go ahead and you send the command to deploy the VFXT cluster. This is obviously assuming you already have your network connectivity all set up back on premises. You have a VPN or a direct link. And then in your on-prem data center, obviously, you have some network-attached storage. In this particular case, we have two exports there, an on-prem data and on-prem archive. And the whole idea there is to say, obviously, I have a workflow that's actively working on my on-prem data, and then I have maybe a workflow that is moving some data onto the archive after it's done processing it. And as can be seen in the very center of the screen here, those same path names, on-prem data and on-prem archive, are being made available in the cloud. So the infrastructure pieces obviously are the network connectivity, the orchestrator, the VFXT cluster, and the compute client instances. And then, as I mentioned earlier, just before I started talking about the demo, your application, right, is typically going to be like a Linux NFS grid application, or highly, or as they call it, embarrassingly parallel application. And then you're going to have it's obviously going to have a CPU-intensive computation workload, and it's going to be very read I/O intensive. Now, let's talk about our pre-flight checklist. So what needs to be in place before we can actually kick things off here, right? So can the orchestrator reach the GCP project network, right? So I'm going to go and share my screen in a little bit here, but I basically have a Google Cloud project. I have an instance there that has a public IP address on it. All I got to be able to do is SSH in there and access that, and that satisfies the first requirement. Then the next piece is, does the GCP project network have a network path back to on-premises NAS? In this particular case, we were working with a VPN link, so there's routed network setup, and the NFS server that sits, quote-unquote, on-premises is accessible from my cloud environment. And then the next requirement is obviously, can the instance that I'm going to be running the VFXT.py library from, which is the orchestration, essentially, can that reach the Google API endpoint? That's obviously critical to be able to deploy stuff like instances, disks, and configure the network. And then is the VFXT Python library installed? And does the GCE instance that you're running this on have the proper permissions to create instances and attach disks and all that kind of stuff? And then obviously you need to pick a region and a zone that you're going to do this in. Maybe it's pricing based, maybe it's data sovereignty based. Your requirements may vary, right? And then the last piece that obviously sometimes creeps up on people are the project quotas set up, right? So every Google project, when you first create it, has some default quotas on them. They're pretty low. They don't allow you to deploy a lot of CPU instances, high quantities of CPUs and stuff like that. So that, or large size disks and stuff like that. So that needs to be in place before you can actually start deploying these things. So now we're going to say, okay, it's time for liftoff. So let's go. Let me just go here to the screen sharing, and let me close this here. And let me start the screen sharing. All right. Okay. So here we have, and let me just blow the font up a little bit here. So here we have our instance inside of my Google project here, and this is my SDK instance, as I call it, where I have the VFXT.py libraries installed. And this obviously has an external IP. I have some firewalls that are rules that are whitelisting my IP. But then basically what I'm going to end up doing is I'm going to SSH into this instance, and then I am going to look at the VFXT directory here, which I've basically downloaded. Avere would provide you with this link to download this library. You would install it, and then you have this vfxt.py Python library here, and it has extensive help about all the options, everything you can possibly consider in terms of deploying these resources and how to configure them, bootstrap, and how to clean them up and destroy them as well. So typically what you end up doing is you run a command that looks something like this, and I'm just going to walk quickly through the switches here. So the first one is on instance, which means I'm running this on a Google Compute instance that's already authenticated to the Google Cloud infrastructure and has all the permissions necessary to do all the successive steps. So first thing is I am on a Google Compute Engine Cloud type, and I'm going to create a cluster, and I'm going to give it a default password, which is the management password for the cluster. I'm going to give it a name, which is how it's going to be referred to, A, through the instance names, and B, also through all the management interfaces that Avere provides. Then I'm going to say which kind of instance types I have, which is the N1 HIMEM32. That's the higher performing instance of the two that we support. I want to use local SSD, which is the highest performing disk that I can attach to these guys. I want to provide a cache size of 375 gigabytes. And then I want to be able to tell my instances to reach the Google API points. That's what this GCE tag use NAT is. I have a NAT instance sitting inside of my project that allows anyone else to reach the Google Cloud API endpoints. And then the last piece is the NFS mount. So this is how I tell the cluster that's going to be instantiated. I have an NFS server with this IP address here that is exporting NFS vol on-prem data, and I want you to go ahead and add that to the configuration of the Avere cluster so that when it comes up, this data will be immediately available to clients that mount the Avere cluster. Last piece is I can give an administrative name to this filer, and we'll see that in the UI. But essentially, when I go ahead and run this, and let's just copy and paste here. There. Okay, so now it's basically going to go and start orchestrating all this stuff. So for the first step is sending the API commands to Google to create the instances, attach the disks, install the operating system. So you don't have to worry about this as an admin of the system. This is being taken care of for you. And then basically once the instances are created and the operating system is running, then we start sending Avere-specific API commands to that system that starts to cluster the nodes together and configure them to talk to the NFS core filer that we configured, provide a set of IP addresses that the clients inside of your environment are going to mount, et cetera, et cetera. Now, in the end, it's going to return you an IP address that you can manage this system through. So I already have a tunnel set up here, and let me just go ahead and pull this guy up. But essentially, what you're going to see here is your instances are going to be automatically created. So like your typical cooking show, I already have 3 of them ready to go, but this live demo 1-1 is the one that I just kicked off the creation for. And by the end of this demo, we'll see that there'll be a -2, -3, and they will all be clustered together. And we can actually go look at those if you guys want. But I'm going to fast forward to the point where the actual cluster is set up, and I've accessed it and logged in with the username and password that have been provided on this invocation of the orchestration. So here I can see I have a 3-node VFXT cluster. They're running on GCE with the N1 HIMEM32s. I have a core filer that is named NFS filer, and then I can go and see exactly what kind of cache policy I have set up for that, which is basically what I was talking about in terms of how we're doing read versus write caching. Then you have things like the namespace that are configured, and the namespace is how we present volumes to clients inside the cloud that are mounting the VFXT cluster. So here I have 2 paths named on-prem archive and on-prem data that map back to this NFS filer and the on-prem archive and on-prem data folder. So now I'm basically ready at this point to take my clients and mount them to the cluster itself. So I have 3 IP addresses here, 10.241.0.5, 0.6, and 0.7. I already have a client image. That's a Linux Debian image that has the FS tab already set up to mount these IPs. And basically, I'm just going to go ahead and fork off some of these workers here. And it's going to go ahead and orchestrate the creation these client instances. And once the client instances come online, they're going to mount the VFXT, and they're going to see an exact real-time replica of the data that sits on-prem. Now, depending on how your workflows and your other workflow orchestration takes place, if you have a queue management system or some sort of batch processing system or whatnot, that's going to dictate how we how these client instances actually start doing their work. So in this particular case, what we're going to end up with is creating these render nodes that are going to go ahead and look for a file that says, hey, I have work for you to do, go ahead and do it. And then they're going to basically read data in, start doing their work, and then output the results. Now, when you do this on a single client, it's not really all that exciting. But when you go ahead and do it across many, many clients, that's where you really start to see the benefits of A, doing parallel work in a large compute environment, and B, being able to really provide the performance that such a workload would require to get the work done. So here we're going to go ahead and let's see. So here it's already starting. We can see in the scroll back buffer here, it's creating these instances, instance 17, instance 6, 22, 13. And once those instances start booting up and are actually live, we're going to see some load start to spin up here on the Avere VFXT cluster. So in the meantime, I can probably refresh my my cloud console here, and I can see, okay, these nodes are already booting up. I have 25 of them that are currently, some of them are started up already, other ones are still initializing. And then once they actually start running, we're going to see the workload activity start to hit the Avere VFXT cluster. So with that in mind, while we're waiting for those guys to boot up, I'm just going to flip back here to the vfxt.py invocation, which I'll walk through it real quick. It creates the first node, and then basically once that is already bootstrapped and running the Avere OS software and has the Avere API listening, we're able to start sending commands to it. So we set up stuff like the node naming policy. So when you start adding nodes to the cluster, how are they going to get named? And that's so you can have a consistent naming mode. Then you have stuff like the licensing, right? So we have a licensing server that is going to go back and talk to make sure that you're setting up a legitimately sized cluster. And then when all of that is verified, it's going to go ahead and create the rest of the nodes in the cluster, because there's really no reason to create the rest of the nodes in the cluster if you're going to fail on these pre-steps. So here is creating the rest of these nodes in the cluster, and we'll kind of let that go in the background. So here I can show I have a client. Let me just blow up the font here a little bit. And here under the Avere dashboard, I have a clients tab, which shows all the clients that are attached and what they're doing. But so basically here we can see all these nodes, these worker nodes that got fired up as a result of the script that I ran. And essentially, they came in and they started reading files. And when you guys ask, well, what files are they reading? I can pull up this hot files tab, and that's going to resolve to the file names and paths that are being accessed by these. So there's some Python libraries, there are obviously some source data and whatnot. But when we look here at the chart, we can see the blue is what the clients are reading, and the yellow is what is being read. The yellow and green are what's being filled in from your on-premises core filer. So here you can see the blue line is really, really high, and then the yellow and green lines are really, really low, which essentially means that you're getting a lot of benefit from the cache. So here we're peaking at 314 megabytes per second, which was, I think, when we had maybe 20 clients running at that point. And essentially what that ends up doing is it leverages, it only pulls a little bit of data off your core filer on premises, and the rest hits the cache. So when we look at our latency charts, we can actually see, let's just get rid of this guy, but essentially when we compare what the workload looks like, when we hit 314 megabytes per second, we were actually seeing a client latency of, I don't know, it looks on the order of maybe 5 or 10 milliseconds, which is really respectable. So this is the benefit of running a read-intensive workload in a VFXT.